Good morning and welcome to Chapter 6. The title of this lesson today is Graphing Systems of Equations. One of the most important things you need to know, hint, hint, is systems of equations can have one solution, infinitely many solutions, or absolutely no solution at all. So let's go ahead and do some highlighting here. So two lines that would intersect have exactly one solution. If two lines or two equations of the same line are in two different forms, perhaps one form is in y equals mx plus b and the other form is in standard. If it's the same line, they're going to share all solutions or have infinitely many solutions. And if two lines are parallel, let's see who can remember something about parallel lines. Parallel lines, let's see, does anybody know a fact about parallel lines? Yes. They never end. Good. Something else. Perfect. Parallel lines have the same slope. They never end. They continue on, and they never meet. So parallel lines have no solution. So important fact number 1, 2, and 3. Systems of equations, look up here, can have one solution if the two lines intersect. They can have infinitely many solutions if it's the same line, or they can have no solution if they are parallel lines. Okay? So the best way for me to test this concept and for us to look at it would be for a graph to already be given to you and for me to ask a question. I'll pick two lines and I'll say, how many solutions do they have? And if it has one solution, I may ask you to name it. Now, on the test, you will see questions like this. You will not be asked to graph it on your own and to solve a system by graphing it. And the reason being is if we're not using a graphing calculator, which we don't use in Algebra 1, we probably aren't going to get the most exact graph. However, graph paper and a nice sharp pencil will definitely help. All right, so we want to use the graph at the right to determine whether each system is consistent or inconsistent and if it is dependent or independent. And I'm going to be honest with you, I basically have gotten away from using that terminology over the years only because students totally mess it up. Your notes and stuff are in the back. So basically what I want you to know is I want you to be able to tell me, do they have one solution, no solution, or infinitely many solutions? So let's go ahead and let's look at y equals negative x plus 2. Y equals negative x plus 2 is this line right here. And y equals x plus 1. Y equals x plus 1. So everybody look at those two lines and then determine in your own mind, do those two lines meet because they're intersecting, have no solution because they're parallel, or have infinitely many solutions in common because they are the same line? If you know the answer, raise your hand. Yes, right here. They have one solution because those two lines intersect. Is everyone with me? For the person who just came in, I just want to reiterate that you should prepare yourself for a pop quiz every day. First game changer would be two lines that intersect have one solution. If it's the same line, they have infinitely many. If they're parallel, they have no solution. So if I were to ask you how many solutions can systems of equations have, you could tell me one, none, or infinitely many. Okay, so let's go ahead and take another example. Let's go ahead and take y equals negative x plus 2, which is this line right here, and let's take y equals negative x minus 1. Basically, I didn't even have to look at that graph to know what my solution would be. Why not? How come I didn't have to look at the graph? I just had to look at the line, the equations. Yes? because they never cross. Okay, that's good. Why else? What am I looking for? What could you tell me? First of all, are the two equations in the same form? Yes, they're both in y equals mx plus b form. So what could you tell me something important about them? They have the same slope. So as soon as I see same slope, I know what kind of lines are they? Parallel. And we know that parallel lines never meet. We know that parallel lines never cross. So two lines that are parallel have absolutely no solution. They don't share anything. Yes, question.
It's just that for the first line, there are two equations, like, so.
Right. These are two different forms of the equation for the same line. So if you were to take this equation, 3x plus 3y equals negative 3, and rewrite it from standard form to slope-intercept, that's what you would get. Are you guys with me? Anybody have a question up to this point? So let's go ahead and make sure that we still remember how to graph. Let's take the last one. And the last one we'll take is this right here. So that's kind of what John was alluding to. So let's just look at it real quickly. So let's take this equation. Y equals negative x minus 1, and 3x plus 3y equals negative 3. So those are the same line, but two different forms of the equation. What could you tell me? How many solutions does it have? Can't hear you. Infinitely many, or all solutions. Do you guys remember touching on this last year in pre-algebra? Okay. No? I know you will when we do tomorrow's lesson. All right, let's take a look. Let's have you do one. Let's use the graph at the right to determine whether the system of... we're going to change the wording here. I just need to know, does it have one solution, no solution, or infinitely many? So let's do 1 and 2. Let's do 1 and 2. Can everybody see that okay? I know it's in your notes as well. And I'm going to be honest with you, it actually helps me to highlight them. So I basically highlight them. Y equals negative x plus 3 and y equals x minus 1. So that's the first set. Let's not do 2. Let's do... all right, we'll do 2. It's okay. Does everybody have 1? All right. And then number 2 is 2x plus 2y equals negative 6. And y equals negative x minus 3. So the second one, I'm going to do in pink. Getting fancy here. All right. Number 1. Who would like it? Number 1. Go back to a pen. Go back to black. How many solutions did you say there, Sweet Pea? 1 solution. Okay. Now, it might ask you sometimes to name the solution, and if it does, you should be able to do so. Okay, number 2. How many solutions? Yes, just infinitely many or all solutions. Does anyone have a question up to this point? Yes. I can't hear you. How is it infinitely many? Okay, let me explain it to you. Let's just erase all of this. So the second system of equations was 2x plus 2y equals negative 6. So let me highlight it again for you. 2x plus 2y equals negative 6 is this line right here. Do you see that? And the second line is y equals negative x minus 3, which is actually... the same line, but just instead of it being in standard form is in slope-intercept form. So when it's the same line, they share all solutions. Does that help? Okay, good. Alrighty. Okay. graphing systems of equations. So one method of solving a system of equations is to graph the equations on the same coordinate plane. We all remember how to graph. We spent a lot of time at the end of last semester making sure that we could graph. If the graphs intersect, they have one solution. If it's the same line, they have infinitely many solutions. I'm going to give you a hint. I would put the graph or put the equation in slope-intercept form. Slope-intercept form. Let's see if we can make that pen a little bit thinner. Okay. Slope-intercept form. And then I would go from there. So let's go ahead and do one together. I know these are in your notes, but let's see if we can do number one together. Graph each system and determine the number of solutions it has. Okay, let's look at the directions. I'm going to give you a major hint for 2019. If you do not read the directions on my quizzes and tests, you are going to lose some very, very big points, guys. Very big points. So here we go. The first equation is y equals -2. Y equals -2 is what kind of a line? If you know, raise your hand. What kind of a line is it? Thank you, Kaylin. The horizontal line. So I'm going to graph y equals -2 right here. And I have rulers for you guys. Okay? So that's y equals -2. Now I'm going to graph my second line in a different color. My second line is 3x minus y equals -1. So I want to do a rewrite into y equals mx plus b. Are y'all with me? Yes? 3x minus y equals 1. Let's just take him over here for a minute. Equals -1? Is it -1? Okay, so we want to solve for y. So we subtract 3x from each side. And I get -1y equals -3x minus 1. What must I do now? Who knows? Go ahead. Divide everything by -1. And I get y equals 3x plus 1. Is that correct? Okay, so what's the slope of that line? 3 over 1. What's the y-intercept there?
I was going to grab you for ITE on my GRE for this period.
No.
You don't? Okay, do you want me? Yes.
Okay, guys, go ahead and graph it and then decide if there's one solution, no solution, or infinitely many solutions. All right, guys, let's see how we did. Let me go back and finish graphing it. So my slope is 3. My y-intercept is 1. I'm going to go up 1, 2, 3, and over 1. What did I do with my ruler? Do you guys want rulers? Here, somebody be nice and get them out. Remember, please give them back when you're done. Thank you. Okay. So how many solutions does this system of equations have? How many? Can't hear you. One solution. And where does it intersect approximately? It intersects at -2, right here.
Yeah.
Isn't that where they cross?
Yeah.
Here's -1, here's -2, and down 2. What's the matter? When I graphed it? Okay, hold on. Let's fix it. Sorry, I was just so excited I got an ITE. Excuse me. All right, let's get rid of him. Let's try it again. Oh, I knew that was going to happen. All right, we'll do it again. This is y equals -2. Is this correct? We're on erase still. We'll just do it all in black. Okay. And then what was my slope? And my y-intercept was what? My y-intercept was 1. My slope was 3. 1, 2, 3, and over 1. Approximately, we extended the graph. It's really hard to do, put a ruler on here and to do this, but we're going to try to cheat. Okay. So what did you get? -1, -2? Okay. So it's one solution. So let me just tell you why on the test, listen carefully, why on the test I am not going to have you do this. Because somebody might say, well, it's not exactly -1, or it's not exactly -2, and be very picky and want to estimate. And what I'm telling you is it has to do with the tip of your pencil, how sharp it is. Using graph paper helps. Using a graph paper is the most important. But I want to bring this to an end here, and I want to end with this. In your notes, I believe is, for some reason, didn't get scanned into mine, but systems of equations can be solved by graphing, and I'm going to slash this here. So let me just go ahead and add in. Let's see if this is going to work. That's not what I wanted to do. Graphing calculator. It's in your notes. Do you see it? Yes? Come on, listen to yourself. Well, I thought I did that before, but evidently I didn't. You know, first day back. Give me a break. At least I'm awake. Even though I stayed up to watch Clemson crush Alabama. Yes, I was so happy. Never happier in my life. Sorry for all you Bama fans, but seriously, Nick Saban needed to have a seat. He made some really bad calls. Like, why would you go for 4th down 3 times? And why didn't you? The fake was like, like my dog saw the fake. Riley's like, what are you doing? I just want to know, like, why you just didn't put points on the board and take the field goal. Although he didn't have much confidence in his kicker, did he? How do you miss the extra point from 10 yards out? That's a very sad day, but it's the way it goes. Okay, so systems of equations can be solved. There are 6 ways. Graphing. Graphing is great because it's visual, right? However, it's not always the most accurate if we're graphing. Graphing calculators, you don't use them until you're way, way advanced. Substitution, elimination by addition, elimination by subtraction, elimination by multiplication. So let me make this story short and sweet. If I were to ask you on a test, on a quiz, name 5 ways to solve systems of equations, okay? Any one of these 6 is accepted. Did you hear me? However, if you just write addition, subtraction, multiplication, no credit, because it needs to be elimination by. Are you with me? Okay, that ends all the fun we can have for today. I'm going to help you guys do a couple of problems, but let's just go ahead and stop this recording.